Hey guys, Coach Sharf here. Welcome back to the videos on the 200-page packet. We are picking back up with page 7. There's actually only 4 questions on this one and only kind of a limited amount of work you actually need to do. Okay? Question 34, just jump into it. In diagram below of circle O, chord A is parallel to chord AB, is parallel to chord CD. Which statement must be true? So this is something we didn't really cover when we were talking about the chords and the sequence and all that. If you'd have gotten this on the ESC, you almost would have had to kind of take a guess, but let's just kind of try to look at it. I told y'all sometimes the diagram's not necessarily going to be true, but let's kind of see if we can figure out just by looking at the diagram, and then I'll kind of try to explain to y'all logically why the correct answer is the correct answer. All right, so first one, arc AC is congruent to arc BD. Again, that's the little congruency symbol in between all of them. Okay, so if I look, the length of AC congruent to the length of BD. Okay, length or degrees. I think they're going for length in this one. Those do look pretty close. Okay, AC and BD. So let's kind of revisit that. AB is congruent to CD. So AB up top, congruent to CD on the bottom. This obviously looks shorter than that one, so let's skip it. Line segment AB is congruent to line segment CD. So this line and this line are the same length. All right, we're told. Excuse me, can't talk. We're told they're parallel. Okay, but are they the same length? Well, that's when you got to kind of think about a circle. Okay, let me draw a line down here. Okay, this might not be the best line, but y'all work with me. Okay, I drew a line down here. Let's pretend that line is parallel to these as well. Okay, so they're all parallel, but being closer to the edge of the circle, obviously this line is shorter than the other two, right? So the lines would basically have to be the same distance from the center to be the same length. Okay, and if you look at it, this line looks closer to the center than that one. So again, might look close, but they're not the same length. And then arc ABD is congruent to arc CDB. Okay, so I've got ABD up there. So coming around, it looks like if A is right here, we're going to say that's cut in half. So if D was down there, it'd be 180. I'm going to say that's maybe like 165 or so. Then CDB. So CDB coming this way. Okay, again, if you kind of look at it, this one's probably hard to judge. If you start at C and went straight through the center, okay, that would be 180. B is a little past that. So kind of by process of elimination, we can get this, okay? The first answer, arc AC is congruent to arc BD. But the mathematical idea is being parallel, okay? It doesn't matter how far the two lines are from the center or how far apart they are from each other. Since they're parallel, okay, you could try to do something to prove this if you want to, but since they're parallel, even if the line was up here, okay, or let me even draw the line ahead, okay, since the circle is so symmetrical going around the point of the center, again, kind of has to do, if y'all remember, why two tangent lines outside the circular segment are congruent, because just the way the shape of the circle works, okay? So if this was E and this was F, since the circle's going the same distance around the center, since it's all focused on the center, if this were AE and this were BF, those would be the same as well. So it's the idea of it being parallel and it being a circle. Okay, so that's going to be answer choice. Sorry, I was looking for the cap for my marker. A. Okay, or answer choice 1, what they have on there. All right. Number 35, what is an equation of circle O shown in the graph below? Well, again, this is going to be the next thing we were going to cover after volume, and we've seen a lot of it now throughout these problems, where is it? Equation of a circle, okay? So again, what we got to remember is H represents the x coordinate of the center. K represents the y coordinate of the center. And they have to have the opposite sign. And whatever is on the right-hand side of my equation is the radius squared. Okay? So if we look at our circle, we can see that the center is -2, +2. And if we count the radius, again, you can just go straight up, straight down, straight left, or straight right. I'm just going to count to the right. 1, 2, 3 till I get the edge of the circle. If you kind of want to go up to double verify it, you can. Up 1, 2, 3 until I hit the circle. So it's got a radius of 3. Okay? So again, looking at my answer choices, if I go back and look at the equation, where is it? My x coordinate and y coordinate have to have the opposite signs, and I got to square the radius. Okay, so again, the radius is usually the key with this one. That'll help narrow down your answers. My radius is 3, so I got to square it to get 9. So that's going to knock out 2 and 4, leave me 1 and 3. So now it's just a matter of the signs. Okay, x is -2, y is +2. When I have an equation, it's got to be flipped. What's next to x has to be positive. What's next to y has to be negative. So that's going to be answer choice 1 right there. Okay, so answer for this one is answer choice 1, or again, if you're doing it A, B, C, D, answer choice A. All right. So we didn't really talk about this. If anything, it kind of looks like we're dealing with a perpendicular bisector, but it's not really, okay? A man wants to place a new bird bath in his yard so that it is 30 feet from a fence and also 10 feet from a light pole. As shown in the diagram below, the light pole is 35 feet away going straight across from the fence. How many locations are possible for the bird bath? So you almost gotta, again, I hate saying common sense, but that's really what you got to do here, okay? So, obviously, I can't put it on this line, the bird bath, okay? Because if it was 30 feet from the fence, if I put it out here, okay, and it was 30 feet from the fence, it would only be 5 feet from the light pole. And same goes the other way. If I actually put it over here where it was 10 feet from the light pole, it'd only be 25 feet from the fence. So I can't put it going straight out between them, okay? So again, it's kind of common sense. You almost got to draw two circles isn't even necessarily the right word, okay? But you almost would have to draw a circle around the light pole that has a radius of 10, okay? So every point on this circle is 10 feet away from the light pole, okay? So again, if this is 35 feet away from the fence, it's kind of almost logic at this point, all right? You would have to think there would be some point down here that's 30 feet away from the fence, and some point up here that's 30 feet away from the fence. All right, it almost kind of is. Again, it's not exact because they're not, the two 30-foot distances aren't coming from the same point. But again, it's kind of the idea about the tangent points. Okay, there's going to be two. We can draw two lines that are the same distance away from an object, and here, and they're also both 10 feet there. Oh, wrong way. And there, right? So, again, something we didn't really cover. I went down and looked at the answer choices. It said the topic is called the locus, okay? That's something we don't cover, but if you want to go look up locus, L-O-C-U-S. L-O-C-U-S. Yeah, I spelled that right. Like focus with the L, okay? All right, so anyway, answer to choice there is 2, okay? All right, diagram below, LMO is a isosceles triangle with LO equaling MO, okay? So LO equals MO. Again, with the isosceles triangle, if the two sides that are congruent, the angles across from them are congruent as well. So that means that that's 55, okay? I'm gonna draw it on my whiteboard so y'all can see it better, okay? But that is how you would start this one off. Okay? L, M, N, O. All right, so those are parallel, or not parallel, those are congruent. So that's 55, that's 55, okay? I know this is 28, we already told me that, okay? Looking at this triangle though, triangle LMO, 55 and 55, that's 110. So my third angle has to be 70 to add a 180, right? But now let's look at my bigger triangle, LNO. Okay, you can almost draw it separately now if you want to. Okay, trying to draw looking through my camera. All right, that's 55. This angle now, 70 plus 28, is 98. Okay, so I got 55 and 98. All right, if we looked, again, all I did, I didn't look at it down here. If measure of angle L is 55 and NOM is 28, which I already had on there, what's the measure of angle N? Okay, so again, the reason why I'm doing this is now, if I look at the big triangle, I have these two angles and I can figure out what N is just by adding these and subtracting it from 180. If I add those, it's going to be 153. Now I'd subtract that from 180, which would be 27. And that is the first answer choice. So answer choice 1, answer choice A, 27. All right. So there's page 7. We'll take a brief pause, regroup, and do page 8. And again, these will all be posted. I'll try to start posting them now before I leave. Go look at this wedding venue. Again, it takes a little while to sometimes upload on YouTube, but I'll let y'all know when they're done. All right, so let me take a quick break, and I'll do page 8.